the answer to number 17. I want you to tell me a way I could find the answer to number 17.
Plug it in Desmos.
Type it into Desmos. If I type it into Desmos, what am I looking for when I type it in?
The x-axis.
Where it crosses the x-axis, because zeros means x-intercept, solution, or root. So which one of these crossed at negative 7, 3? C. Now, I did it a different way. Does anybody know another way I could have done it? Magic. I would like to try that out, but I don't know any magic ways to do it. Solve it how?
On paper.
Can you be a little more specific? Using what method?
A pen.
Yeah, that was more right.
As opposed to a pencil. You could use the quadratic formula. You could factor it. You could complete the square. I actually use factoring, and let me show you how I use factoring, and it was faster than Desmos. Because to factor, I need to say what multiplies to give me negative 21, but adds to give me 4. And that would be 3 and negative 7. But I did something before that, and I forgot to tell you what I did. I knew that if the zeros were at negative 7 and 3, that when it factored, it looked like this. Because I'd have to set each piece equal to 0, and if I set this equal to 0, I'd get negative 7. If I set this equal to 0, I'd get 3. So what I was trying to find is which one factors to look like this. So which one would have 7 and negative 3 to make positive 4, and 7 times negative 3 to get negative 21. So that's how I did this problem. But that's still the answer you should have got with Desmos. And that is just fine because you get to use the Desmos calculator on the EOC. What method should you have used on number 18?
Desmos.
You could use Desmos, but there is a faster one, but Desmos will work.
Desmos is
The quadratic formula.
Desmos is faster only if A is the answer, which in this case it is, but it will not always be the first one. If D was the answer, my method would be faster. Quadratic formula would work, but the fastest way would be to use the zero product property. If this already in factored form, you just set each piece equal to 0 and solve. Subtract 1 divided by 2, you get 1/2. Add 5 divided by 3, you get 5/3. I actually did those two sets in my head instead of writing them down. But I've been doing this a whole lot longer than you. So my suggestion is try that and then check the one you think it is in Desmos to make sure you're right. If it's in factored form, try setting it equal to 0. For instance, I could look at B and tell you it's not the answer. Because x plus 2, if I set that equal to 0, I get negative 2. And was negative 2 one of my answers? No. I could do the same thing for D. So I've just knocked out 2 answers without having to type either one of those in Desmos. And that would leave me just 2 to type in Desmos. Then we get to number 19. Ooh. On number 19, there's a little bit that got left out of the directions. On number 19, on the common assessment, when it looks like this, it's going to say, it's going to have multiple choice answers. So you'll be able to look at them to kind of see what they want. But here, there's nothing to look at to see what they want. So I want to put simplify using rational exponents, which means my answers are going to have exponents in them. There shouldn't be an N right there. Exponent instead of square roots. What power are we raising something to if we take the square root?
2. 1.
The root goes in the denominator. So square root is the second root. So 2 goes in the denominator. What goes in the numerator? 1. So I could rewrite this as x to the third y squared all over z to the fifth to the 1/2 power. And if you don't have that in your brain yet, I understand, but we got to get it there. The square root is the same thing as the 1/2 power. And then I use my power rules to get the answer. I asked this in third period, and I did not get a great response. I'm going to ask again, hoping somebody remembers. When I raise a power to a power, what do I do to the exponents?
Multiply.
Multiply. Very good. So 3 times 1/2 is 3/2. 2 times 1/2 is 1. And 5 times 1/2 is 5/2. Now, you might be saying, Miss Dix, I don't multiply fractions well because I never learned how to do that. What will multiply fractions for you?
Desmos.
Desmos. So you just have to know to type in 3 times 1/2 and hit enter, and it'll do it for you. So this is an answer. But if you're looking at it on this test, it'll have it written like this. And that's a Z, not a Y. I don't know why I put a Y on the bottom. What's different about that?
It's not in a fraction.
It's not in the denominator. If it's in the denominator and it's positive and I want to move it up, I have to make it negative. I actually would prefer it to look like this, but this is not an option when you're taking the common assessment. This is what it'll look like on the common assessment. This is a square root. What if it was a cube root? What if it had a little 3 right there? We wouldn't raise it to the 1/2 power. What power would we raise it to?
1/3.
1/3. What if it was the 4th root?
4th.
We'd raise it to the 1/4 power. If it's the 100th root, you'd raise it to the 1/100. So whatever number is right here goes in the denominator of the exponent. If there's not a number there, then it's a 2, because the only one that doesn't have a number there is a square root of 2. All right, one more mini lesson, and then you'll try some from that on your own. But here it is. I pulled out a calendar today during planning because I wanted to see, when are our tests? How much time do I have to get you ready for the EOC? Because the EOC is how much of your grade? 10% of the whole year. Not just this 9 weeks, the whole year. So, here's today, the 6th. Monday and Tuesday, we have a common assessment, which means I will not be able to teach you on those days because you'll be taking a test. The next 3 days, probably 4, I will work on our next unit of comparing, and we'll probably take a test on Tuesday or Wednesday on that. I've got to teach you dimensional analysis. That's something we were supposed to do earlier this year, but I skipped it because I wanted it to be in your brain closer to testing because it's something most students forget. Then I'm going to review linear probably for 1.5 to 2 days. Then I'm going to review systems for 1.5 to 2 days. And the reason is because you have to know those 2 things on SC Ready for 8th grade and the EOC for algebra. These 3 days I'll have to review for SC Ready and the EOC. There are a few things that you're supposed to know on SC Ready that I haven't taught you this year. You were supposed to learn them last year in honors, but we know how that goes about when you're supposed to learn stuff in previous years. The next Monday is Memorial Day, so we won't have school. Regular school day, 2 days of testing, and your social. I shouldn't write dance here. I should write 8th grade social. Which means there's 3 days that I'll only see you for part of a class unless you're not going to the social, and then you'll be here. The week after that, Monday's a regular day, and Tuesday's SC Ready Math, regular day, and then the EOC. So I really have like 2.5 weeks left with you to get you ready for 2 major tests.
Oh, God.
And to give you a test on top of that. So when I give you homework over these few days, it's not because I'm trying to be cruel. It's because I know that if you don't do a little bit of this at home, we're never going to get through it. So let me look at this little mini lesson here. This is an 8th grade lesson and an algebra lesson. So you need to listen up because this could be on either test, SC Ready 8th grade or EOC. Rational numbers. I have mentioned rational numbers, I think, at least 3 times in this class. However, I've never made you write anything down about it. So, by the way, the reason I'm saying all that is because those of you who are looking at your phones in your desks, who are wearing your earbuds in here and listening to other things while I'm teaching, who are on other websites while I'm teaching, who are just zoning out, you are hurting yourself. For like half a second, your EO scores reflect on me because I look at them and I kind of figure out, oh my gosh, how did the kids do? After that, it's all you. Next year, I get a new crop of kids, but guess what doesn't disappear for you? Your grade in this class. It follows you all the way to college. So if you choose to do those things, I get it. But this is on you. It's not on me. I'm doing the best I can to give you the information, but the score travels with you. It doesn't travel with me. I get a new batch of kids next year and look at their scores, and then they move on, and a new batch happens over and over and over. Rational numbers. Numbers that can be written as fractions are rational. The fraction has to only contain integers. It can't have like square roots in it and stuff. If the number is a decimal and it's rational, it's a decimal that terminates, which means it stops, or a decimal that repeats. So if the decimal stops, it's rational. If the decimal repeats, it's rational. But if the decimal goes on forever without being a repeating decimal, it is irrational. The first irrational number you're normally introduced to is pi. It's a number that goes on and on and on and on forever without repeating the same number over and over and over again. But now that you're in algebra, there's a new irrational number we're looking at. If you take the square root of a number that is not a perfect square, it is always irrational. So for instance, the square root of 2. 2 is not a perfect square, so it is irrational. Square root of 3, irrational. Square root of 4, is 4 a perfect square? Yes, therefore that is rational because the square root of 4 is 2. A decimal that stops. Can you give me an example of a decimal that stops?
1.1.
1.1, that's a terminating decimal. 5.39. If it goes to 8 decimal places, but it stops after 8 decimal places, it still stops. However, in a calculator, they can only hold 9 to 10 digits. So it'll go like 9 to 10 digits in the calculator and stop, but it really goes on and on forever. And I'll show you an example of that. So what they want to know here is tell if the sum is rational or irrational. So I'm going to do the first one with you. Square root of 9 plus 1/2. What is the square root of 9?
3.
3. And what's 3 plus 1/2? 3.5. Can that be written as a fraction? Yeah, it is a fraction. So that answer is rational. You could also type it into Desmos and it'll give you 3.5, which is a terminating decimal, which tells you it is rational. So what I want you to do here, I want us to go down to number 21. I want to look at some of that one with you. On 21, square root of 2 times 3 square roots of 8. We would multiply, if we were doing this by hand, the numbers out front. What's 1 times 3? 3. And then what's under the square root we would multiply? What's 2 times 8?
16.
16. Is 16 a perfect square?
Yes.
Yes. So square root of 16 is 4, and 3 times 4 is 12, which makes that a rational number. It'll be irrational if you have a number under the square root that is not a perfect square when you finish. So what I want you to do right now is I want you to take a moment. You can use Desmos, you can use your brain, you can work things out on paper, but I want you to try 20 and 21, and you're just going to circle rational or irrational for every bullet there.